Hello everyone and welcome to 30 days of DSA challenge, where we will be solving a DSA problem every day for the next 30 days. So this is our day number 8, where we will again solve a problem based on linked list, and the level of this question is going to be medium. The name of this question is linked list cycle. You will get this question link in description, and you can also download this Excel sheet from description. So without wasting much time, let's see our question on Leetcode. So this is our question on Leetcode. Let's read it. So it says, given the head of a linked list, determine if the linked list has a cycle in it. So basically we have been given the head of a linked list, right, of a single linked list, and we have to find, is there a cycle present in that particular linked list or not. So there is a cycle in a linked list if there is some node in the linked list that can be reached again by continuously following the next pointer. So this is kind of a definition of what is the meaning of having cycle in linked list is. We will look into it again when we will do some dry run, so don't worry about it. Internally, POS, that is a kind of short form for position, is used to denote the index of the node that's tail's next pointer is connected to. Note that POS or position is not passed as a parameter. So basically you do not need to much worry about what is this POS or position, because we do not need it. We just need to give true or false, either the cycle is present or not. We do not have to do anything with the position of the cycle, right? And it says return true if there is a cycle in the linked list, otherwise return false. So this is our question. We have to return true if the given linked list have a cycle, or we have to return false if it does not have a cycle. So let's understand it by taking some examples. Okay, so first let's try to understand what is the meaning of cycle, right? What is the meaning of cycle in linked list? So let's say we have this linked list. It have 1, 2, 3 and 4, and now the next pointer of 4 is pointing to another node, that is 2, and here is the head of our linked list. So here we can clearly see that there is a cycle, right? There is a cycle between 2, 3, 4, right? We can clearly see that here we have a cycle, right? So for this particular input we will return true, right? Similarly, let's take some more examples. Let's say we have 1, 2, 3, and this 3 is pointing to 1, right? 3 is pointing to 1, and here is our head pointer. Now again you can clearly see that yes, there is a loop, or you can say there is a cycle. There is a cycle present in this linked list. Then we will also return true in this particular case as well. Now let's say we have, let's take another example. Okay, so let's say this is our linked list and head is pointing to 1. Now we can clearly see that we do not have any cycle present in this particular linked list, right? We do not have any cycle present in this particular linked list because it is getting terminated. It is getting terminated at some point. So for this particular test case we will return false, right? And also there are some edge cases. Let's say if we only have only one node in our linked list, then we can, what we have to return. So it is pretty simple. When we have just one node, it means that there is not any cycle, right? So we have to return false in this particular case as well. And let's say in the input we got one empty linked list, right? We got one empty linked list, right? We got one empty linked list. So if we got one empty linked list, then how we can determine do we have a cycle or not, right? So in this particular case as well, we will return false, right? We will return false because in the constraint of the question, if you read it properly, it is mentioned that number of nodes, right? Number of nodes in our linked list can be zero as well. So it is basically stating that if we are getting an empty linked list, then what we have to do. So if it is an empty linked list, then we will return false. And we will see in the question if any specific test case get failed, then we will think about it, what to do in that particular scenario, right? Okay, so now I hope you know what is the meaning of a cycle in English. Now let's think about the intuition, right? Let's think about the how intuition, how we are going to solve or how we are going to approach this question. So for this, let me just take one sample test case. Let's say we have 1, 2, 3 and 4, and this 4 is pointing to 2, right? This 4 is pointing to 2. So and the head is pointing at node number 1, right? So now from your naked eyes you can clearly see that yes, there is a cycle present here, so we have to return true. But we'll think about the intuition, right? How we will build our intuition. Okay, so how, like, just ask yourself how you got to know that there is a cycle present, in this particular linked list. Just ask yourself, ask your brain, how you got to know that there is a cycle, right? So let's say if we just do a normal traversal, right? Let's say we are just doing a normal traversal in this linked list, and by doing a traversal, can we determine cycle? Let's see. So firstly, I am here, let's say I am using one pointer named as cur, right? So firstly I am here at node number 1. Okay, then I moved to the next node, that is node number 2. Okay, again I'll get moved to the next node, that is node number 3. Again I will move, let me just cut it. Okay, again I will move to node number 4, right? From node number 4, remember, from node number 4 I will again go back, I will again go back to node number 2, right? I will again go back to node number 2. Now one thing if you have observed, then this particular node, right, this particular node has been visited twice, right? It has been visited twice, right? It has been visited twice. You can see with the different colors. One when we are doing a traversal, one with this green color and one with this yellow color, right? So basically it is a kind of observation that if we are doing a traversal in our linked list, and if we are coming at a particular node twice, basically more than one times, right, then we can say that yes, there can be a cycle, or there is a cycle, right? Now let's take one more example. Let's say we have 1, we have 8, we have 10, we have 12, and we have 13 as well, and now this 13 is pointing to 1. Okay, and here is our head. So let's just do a normal traversal, right? Let's just do a normal traversal. Okay, so for traversal I will use a pointer named as cur, right? We will use a pointer named as cur, and initially my cur pointer will be pointing to my head, right? Because I am doing a linear kind of traversal. Okay, so firstly I'll come and visit this node number 1, then I will move to node number, right, this node which have 8, right? Then I'll move to this particular node 10. Okay, then I'll move to node number 12. Okay, then I'll move to node 13. After 13, just see it very clearly, right? After 13, what we are doing, we are again coming back to node number 1, right? So I will again come back at node number 1. Now here again, if you have observed clearly, then we are kind of reaching this particular node number 1 twice, right? Once when I was using this white color, and once when I am using this green color. So kind of now we can say that if we are reaching any node, right, any node more than one time, right, that means there is a cycle. And you can clearly see that there is a cycle present in this linked list, right? So this is our intuition. Now we'll think about how to implement it, right? So what do we need? We need to remember, kind of, right? We need to remember that how many times we have visited any node, right? We need to know how many times we have visited any node, or more specifically if I say, then we need to know, right? We need to know, or we need to remember that we have visited the current node previously, right? Yes or no, correct? Now if we have visited any node previously, if yes, then we will simply return true, that yes, there is a cycle. Yes, there is a cycle, because if we see this particular example, right, if we, let me just rub it. Okay, so if we see this particular example, then we had already visited this node number 1, and we were visiting it again, right? So that we came in a conclusion that yes, there is a cycle present in this linked list. So this is the intuition, and the best data structure to know, right, to know or to remember that we have visited any particular node or not is map or an unordered map. So what we will do, we will use an unordered map to remember this, right? Now let's do a quick dry run, then we will move to coding part. So let's take one example. We have 1, 2, 5, 8, and this 8 is pointing to 2, right? And our head is pointing at node number 1. Okay, so now what we will use a map data structure. It will have two things. Very first one is the node, and second a boolean value, right? A boolean value. Okay, so initially let's say we are using a pointer named as cur, and initially the cur pointer is pointing at the head, right? So we will check do I have visited this node previously or not. Now how I will get to know this? I will ask this to my map. In my map data structure, I will check that is this node number 1 is present or not. Is it present or not? So you can clearly see that in our map data structure, this node number 1 is not present. If it is not present, it means that we are visiting it for the first time, right? It means that we are visiting node number 1 for the first time. Okay, now if we are visiting it for the first time, what we'll do, we will just enter it, right? We will write 1 and we will write true, right? Why 1 and true? 1 and true. 1 means that we have visited node number 1, right? And this true says that we have visited node number 1 for the first time, right? We are visiting it for the first time, or we have visited it for first time, or only once, right? We have visited node number 1 only once. Okay, okay, clear. Then what we'll do, we will move our current pointer, right? So now my current pointer is at node number 2. I will again check, is it present into my map? Is it present into my map or not? So my map will say no, it is not present. If it is not present, then simply just put it into my map. So I'll write 2 and I will write true. Now what does it mean? It means that I am visiting this node number 2 for the first time, right? And I have visited it for the first time. Okay, then I will again move my current pointer. So now my current pointer will come at this node 5. So I will again check, is this node is present? Is this node is present into my map data structure? So my map will say no, it is not present. Now if it is not present into my map data structure, then it signifies that I am visiting this particular node for the first time. So what I'll do, I'll just put it into my map, right? I will put 3 and I will put true, right? Now why true and why 3? Sorry, it will not be 3, it will be 5, right? It will be 5. Now why true? This true signifies that I am visiting this node number 5 for first time, right? This is my first time and I have successfully visited it. That's why I have written true here. Okay, now this cur will move ahead, and now the cur pointer will come at 8. Again I will do the same thing. Again I will ask my map, do I have visited this node previously or not? So my map will check. In the map data structure, this 8 is not present. If it is not present, it means that we have not visited it previously. That means we are visiting it for the first time. If we are visiting it for the first time, we will just put it into our map, right? We will just put it into our map and we'll write true here, right? Why true? Because we have successfully visited it and we have visited it for first time, okay? So now from here my current pointer will go to this node number 2. Now my current pointer is here at node number 2. Now I will again check, right? Now I will again check, or I will again ask to my map, do I have visited this node number 2 previously somewhere? Now my map will check in the map data structure, is 2 is present in the map or not. So now my map will say yes, 2 is present, 2 is marked as true. It means that we have previously visited 2, right? It means that we have previously visited 2 and now again we are coming at node number 2. It simply means that there is a cycle, so we will return true, right? So this was the basic approach, and this was the intuition. So I had also explained you the intuition behind this particular approach, and I had also done a small dry run. So I hope you are clear with the concept, you are clear with the intuition as well. So now let's just write a quick pseudocode. So what do we need? We need firstly one unordered map, right? We will write one unordered map, and it will have two things: firstly the node, and secondly a bool, right? Boolean value. And let's just name it as visited, right? Let's just name it as visited, right? Visited just because it is telling us that we have visited this particular node previously or not, right? You can name it something as something else as well, it's up to you. Okay, then what we need, we also need a pointer, like current pointer, which will be initially pointing to head. Then what do we need? We just need to do a normal traversal, right? So it is very simple. We'll write while null current is not equal to null, right? Okay, now what we have to do here, firstly we have to check, right? I need to check, right? I need to check I have visited this particular node previously or not, right? I have visited this particular node previously or not. For that I will write one condition, right? For that I will write one condition, that if the visited of current is equal to true, right? If it is equal to true, it means that I have previously visited. Now if I have previously visited one node and I'm again visiting it, it means that there is a cycle, right? So I will simply return true, that yes, there is a cycle, there exists a cycle, right? Now if it is not true, right? If it is not true, then it means that we are visiting that particular node, right? We are visiting that particular node first time, right? First time. Now if we are visiting this particular node for the first time, what we have to do, we just have to put it into our map, right? So we will write visited of current equal to true, right? Okay, this is done, and at the end we are doing a normal traversal, so we will move to the next node. So therefore we will write current is equal to current next. Okay, now see this code, right? If there is a cycle, right? If there is a cycle, then from this particular line true will be returned, right? But what if there is not a cycle? What if there is not a cycle? Now if there is not a cycle, then this line will never get executed, right? Then this line will never get executed, and eventually we will come out, right? Eventually we will come out of this while loop, right? So if we have came out from this while loop, that means what? It means that we haven't encountered any cycle, or we haven't encountered any node that we are visiting second time, right? Then we can simply return false. It simply indicates that there is not any cycle present in our linked list, right? So this was our code, right? This was our code. It is pretty simple and straightforward. So let's just discuss the time complexity. So the time complexity is going to be very simple. We are just using a while loop, and we are doing just one normal traversal on our linked list. So if the size of our linked list is n, then we can say that the time complexity is big O of n, right? Similarly, if we think about the space complexity, then you can clearly see here that we are using a visited map, right? We are using a visited map, and what is it going to store? It is going to store all the nodes and a Boolean value, right? Now how many number of nodes do we have? Let's say that we have n number of nodes. Then what is going to be the size of our map? In the worst case, it will be same O of n. So these are the time and space complexity of this particular code. Now without wasting much time, let's code it up. So now we are here on Leetcode, so let's code it up fastly. So what do we need? We need one unordered map, right? We need one unordered map named as visited, and what it is going to have, it is going to store our node and a boolean value, right? A node and a boolean value. What's the second thing we need? Secondly, we need a pointer named as cur, which will be initially pointing to our head, right? Which will be initially pointing to our head. Then what do we need to do? We need to do a normal traversal, right? So we'll write while cur is not equal to null, and here we will do cur is equal to cur next, right? This is our normal traversal, right? Now at every particular node, we will check that I am visiting it for the first time or I have already visited it, right? So therefore I will write a condition that if visited of cur is equal to true, right? What does it mean? It means that I have previously visited this node, right? That means I have previously visited this node. Now if I have previously visited, I am visiting it again, it means that there is existing a cycle. So for that we will return true, that yes, there is a cycle. Now else, let's talk about the else part. Now if I am visiting any node for the first time, then what do I need to do? I just need to put it into my map data structure, right? Nothing else. We'll write visited of cur and we'll mark it as true, that yes, I have visited this particular node, right? Now after doing this, we do not need to do anything. Now if this while loop is over, and there is not a cycle, then this return statement will never get executed and will come out of this while loop, then we can simply return false, indicating that there is not a cycle in this linked list. So this is our code. Let's run this. Okay, so you can see that all the 4 sample test cases are running fine. Let me just submit this. So you can see that this particular approach, this particular code is accepted, and the time complexity and space complexity was O of n, right? Now let's think of, can we optimize this particular approach or not? So now let's think about can we optimize the previous approach or not, and if we can, then how we can optimize it. So the time complexity of the previous approach was O of n and the space complexity was also O of n, right? Now we are trying to optimize it. So now let's think about, can we solve this problem without using the extra space, right? It means that can we solve it in a constant space or O of 1 space, right? Now one thing is very clear, that if we are saying that we have to solve this particular problem in O of 1 or in constant time, it means that we will not use any data structure, right? We will not use any data structure to remember that we have previously visited this particular node or not, right? So this thing is clear, I think, right? Now if this particular thing is clear, that we are not using any other data structure to remember that we have visited that particular node previously or not, it also means that we have to do some, right? We have to do some operations, right? We have to do some operations on the linked list itself, right? We have to do some operations on our linked list itself to find that there is a cycle or there is a not, right? Okay, so is this thing is clear. Now one thing which I want to mention clearly is, to solve this problem without using any extra space, we will use the concept of slow and fast pointers, right? We will use the concept of slow and fast pointers, and I personally believe that this particular approach is not much intuitive, right? So if you do not know about the concept of slow and fast pointers, then it is very hard to think about this kind of approach or to think about the intuition, right? So if you know about this, then you can clearly think about this approach in your interview or in your online assessment. But if you don't know, right, if you haven't solved any problem using slow and fast pointer approach, then getting the intuition of this particular approach is quite difficult, right? Quite difficult. So this is one thing which I need to say. Now let's think about how this particular thing works, like slow and fast pointers, how they work. So let's take one example. Let's say we have this particular linked list, right? This particular linked list, and there is a cycle, and here we have our head, right? Head is pointing to node number 1. Okay, so now as the name suggests, slow and fast pointers, right? So we will use two pointers, right? We will use two pointers. One is named as slow and other is named as fast, right? So initially the slow pointer will be pointing to the head, right? Initially the slow pointer will be pointing to the head, and our fast pointer will be pointing one step ahead, right? One step ahead, or you can say that the next node of the head, right? The next node of the head. So fast will be pointing here initially, right? Initially fast will point to this node and our slow will point to this node. Okay, now why it is named as fast, why it is named as slow? It is very simple, because every time our fast pointer will take two steps, right? Our fast pointer will take two steps and our slow pointer will take one step only, right? It will take only one step, right? So initially our slow and fast pointers are here. Slow pointer is at 1 and our fast pointer is at 2, right? So now as I said, fast pointer will take two steps and slow pointer will take one step. Okay, so firstly we will move our fast pointer, so it will take two steps. So this is step number 1 when it comes at node number 3. The second step, in the second step it will come at node number 4. So now I can say that my fast pointer is pointing at node 4, right? Fast pointer is pointing at node 4. Okay, so we have done one thing, we have moved our fast pointer. Now what we'll do, we will move a slow pointer, and as I mentioned that it will take one step. So the one step, after taking one step, our slow pointer will come at node number 2, right? Our slow pointer will come at node number 2. Now this is the kind of process which we have to do repeatedly, right? This is something which we have to do repeatedly. So now again what we'll do, again this fast pointer will take two steps, right? So if we take first step, it will come at here node number 2. In the second step it will come at node number 3, right? In the second step it will come at node number 3. So now my fast pointer will come here, right? My fast pointer will come here. Okay, so the fast pointer is here. Now what we'll do, we will move a slow pointer, right? We will move our slow pointer. Now we know that our slow pointer takes one step, right? It takes, or it moves one step. So when our slow pointer will take one step, it will also come at node number 3. It will also come at node number 3, right? So now my slow pointer will also come at node number 3. Now this is the point, when our fast and our slow pointer, they both are at the same node. Our fast and our slow pointer both are at the same node. Now this is something which we need to understand, that if our slow pointer and our fast pointer are pointing at the same node, it means that there exists a cycle. It means that there exists a cycle. Now you may question that how you got this, right? If the slow and fast pointer are on the same node, how you can say that there will definitely exist a cycle? So there is a proof of this particular approach, which we are definitely not going to discuss in this particular video. There is a proof, you can easily find it on Google or on YouTube, so you can watch the proof from there. But for this particular time, you need to understand that if at any moment, if the slow and the fast pointer are pointing at the same node, it means that there is definitely a cycle present, right? It means that there is definitely a cycle present in our linked list. Now let's take one more example. To understand it in a more better way. So let's say we have 10, then we have 12, then we have 18, then we have 13, and then we have 19, and now this 19, right? Now this 19 is pointing to node number 18, right? So you can clearly see that there is a cycle, and initially my head will be pointing at node number 10, right? So we will again use the same concept, slow and fast pointers. So my slow pointer will be pointing at head and my fast pointer will be pointing one step ahead, right? One step ahead, or the next of the head, So my fast pointer will be here, right? Now we clearly know that our fast pointer will take two steps and slow pointer will take one step. So initially my fast pointer will take one step to come at this node, and again it will take another step to come at this node number 13, right? To come at this node number 13. So now I can say that my fast pointer is pointing at node number 13. Okay, Now we know that our slow pointer will take just one step. So it will take one step and it will come at node 12, right? So now my slow pointer will come here. Okay. So now again we know that our fast pointer will take two steps, right? It will take two steps. So from it, if it take one step, it comes at node number 19. If it again takes one more step, then it will come at node number 18, right? Then it will come at node number 18. So now I can say that my fast pointer will be at node number 18, right? My fast pointer will be here at node number 18. And okay, so it got rubbed by accidentally. Okay, so now the fast pointer has moved. Now this is the chance of a slow pointer. We know that our slow pointer take one step, right? So it will take one step and it will come at node number 18, right? And then it will come at node number 18. So now you can clearly see that our fast pointer as well as our slow pointer are pointing on one node, right? On one node. What does it mean? It means that there exists a cycle. There definitely exists a cycle, right? So I hope now this particular approach is clear. Do some dry run, and if you have doubt with the proof, then you can watch or you can refer to any other video or any other article, right? So now let's think about the pseudocode, how we are going to code it up. So coding is very easy, right? We just need two pointers initially. We will need fast and we will need slow. So our slow will be pointing to head and our fast will be pointing to next of our head, right? Next of our head. Now there is a test case, right? There is a test case, edge case, we can say that. Let's say we have a linked list like this, right? We have a linked list, right, like this, right? Now when we write this, that slow is pointing to head, it means what? It means that our slow is pointing here, right? And when we write fast is equal to head next, that means we are trying to point our fast pointer here at null, right? So this is not right. Okay, so what we will do, we will address this particular edge case externally, right? So we will write one different case for this particular case, right? For this particular test case. So how we are going to do that? We will just write one if condition, that if my head is equal to null, right? Or the next of my head, so let me just rub it up. Yeah, okay. And if the next of the head is equal to null, then I have to return false, right? Then I have to return false. Now what is the meaning of this? That head is pointing to null. It's something like our head is pointing to null. It simply means that we have one empty linked list, right? If there is a empty linked list, that means we do not have any node on that particular linked list. And if we do not have any node, how we can say that we have a cycle or not? So we'll simply return false, right? Similarly, this case means that when we have only one single node, right? If we have only one single node, right? If we have only one single node, then we can also say that we do not have any cycle, right? We do not have any cycle, therefore we have returned false here. Okay, then what we will do? Then we will simply do our traversal. So we will write while, let me change the color. So while this slow is not equal to null and this fast is also not equal to null, what we have to do? We have to move our fast pointer twice, right? Two steps. So first step, it will do like this: fast is equal to fast next, right? Now we need to check, right? After moving our fast pointer one step, we need to check that is my fast pointer is pointing to null or not, right? Null or not. If it is pointing to null, then it will not make any sense if I move it one step ahead, right? Let me just explain you. So let's say we have something like this, right? We have something like this. Okay, we have something like this, and now let's take one scenario that our fast is pointing here, not this. Let's say, yeah, our fast is pointing here, right? So it will take two steps, right? We know that it will take two steps. So in the first step, it will come at this particular node, right? Fast will come here. So what we are doing, we are checking that after moving one step, my fast is standing on null or not. So you can clearly see that it is not standing on null. Then what I can do, yes, that means that I can move my fast pointer one step ahead more. So now my fast pointer will come here, right? Now let's take one other example. Let's say that my fast pointer is now pointing at node number 3, right? My fast pointer is pointing at node number 3, and I did this, right? I did this thing, fast is equal to fast next. So now by taking one step, my fast pointer will come here, right? So now we can see that our fast pointer is pointing at null, right? If it is pointing at null. Now if it is pointing at null, can I move it one step ahead? The answer is no. Because there is not any other node present. So therefore we need to check that whenever we are moving our fast pointer by one step, we need to be sure that our fast pointer is not pointing to null, right? So therefore we will write a condition that if our fast is not equal to null, then we can move our fast pointer one more step ahead, right? Okay, and after this what we have to do, we have to move our slow pointer as well. So our slow pointer will move one step ahead, right? And we need to check that if at any point my slow is equal to my fast, right? If at any point slow and fast both are pointing on the same node, right? So if they are pointing on the same node, it means that there is a cycle, and if there is a cycle, I will return true, right? And at the end, if there is not a cycle, then this line will never get executed and we will come out of the loop. So we will simply return false, right? So this is our code, right? Code is pretty simple. And if we talk about the time complexity, then it is very simple. Approximately O of n. We are doing a normal kind of traversal in our linked list. And if we talk about the space complexity, then we are just using some couple of pointers, slow and fast. So you can say that the space complexity will be O of 1 or constant space. So this was this particular approach by using slow and fast pointer. So let's code it up fastly. So now we are here on Leetcode. So let's code the two pointer, or we can say the slow and fast pointer approach. So for that we need some couple of pointers, but before that we have to check that if my head is equal to null, it means that I do not have any node in my linked list. Basically means that I got one empty linked list. Or we can say that if the head next is pointing at null, it means that we have just one node. For this particular case we have to return false, right? And then we will make our two nodes. So first will be our slow, which will be pointing to head, right? And the second will be fast, which will be pointing to head next, right? Okay, so this particular thing is also done. Now what we need to do, we need to do a normal traversal. So we'll write while slow is not equal to null, and my fast is also not equal to null, right? Then what I need to do, I need to move my fast pointer. Two steps, right? Two steps ahead. So let me write it. Let me just move it for the first step. So after moving for the first step, I will write fast is equal to fast next, so that I have moved my fast pointer one step ahead, right? Now after moving one step, I will check that is it pointing to null or not, right? So for that I will write if my fast is not equal to null, right? If it is not pointing to null, then what I can do, I can move another step, right? Okay, then I just need to move my slow pointer as well for one step. After moving it, I will just check that if at any point my slow pointer and my fast pointer are pointing at the same node, then what I have to do, I have to return a true, because there is a cycle, there exists a cycle, and if not, then I will return false, right? So this is our code. Firstly, we are just thinking about, or we are taking care of some edge cases, that if we got one empty linked list, or if we got a linked list where we only have one node, then we have to return false, because there will not be any cycle, of course. Then we are making we are using two pointers. One is the slow, which is pointing to head, and fast is pointing to one step ahead of the head, right? Which is the next of the head. So now we are doing a kind of normal traversal. We are just moving our fast 2 steps. So this is our step number 1 and this is our step number 2, right? So before moving it to the second step, before moving our fast pointer to the second step, we are just checking that is it pointing to null or not. If it is not pointing to null, then I can move it to the next step, right? And we are just moving our slow pointers by 1 step, and we are just checking that if at any point my slow and fast pointer are at the same node, then I will return true. And if there is not a cycle, then slow and fast pointer will never commit same node, and we will come out of this while loop. So then in that case I am returning false, right? So now let me run this. Okay, so now you can see that all the 4 sample test cases are working fine. So let me just submit this. So now you can clearly see that this particular approach is also accepted. So this was all for day number 8 for this video. We will meet again tomorrow with the next question. But if you like this video, if this video was helpful to you, make sure you like this video, make sure you comment your experience if you faced any difficulty or if you have any different approach, and do subscribe to this channel so that you will get this kind of content regularly. We will meet tomorrow again with a new question.